Hello everyone, I welcome you to this exciting stage of the BIM Coordinators Summit 2023. This presentation is going to explore the real-time data management techniques used in digital twin technology. I would like to introduce myself. My name is Olayemi Usman. I'm currently having my MSc degree in the University of Northampton, England, where my focus is on BIM-enabled sustainable buildings. I currently work as a sustainability project QS for Southern, and I'm ambassador for Zero. I would like to give you an introduction about what is digital twin. In simple terms, digital twin it's a virtual representation of the physical objects, processes, or systems. It is like having a doppelganger of something in the real world. This is a virtual counterpart that is connected to its physical counterpart through sensors, data, and real-time communication. So we could say a digital twin technology is a combination of BIM, data, and sensor. The first objective we are going to talk about here is how does digital twin actually works. We are going to see the rudiment, what it entails for you to say that okay, this is actual digital twin figure. Now we are going to be looking at the application of digital twins, the various places that we can apply digital twin technology. Also, we are going to be looking at the real-time data management techniques. There are various steps that you can take to achieve these data management techniques with digital twin. So we are going to be looking at the step-by-step guide on how to do it. Next, we are going to be talking about the benefit of digital technology, and finally, we are going to be looking at the challenges and opportunities of digital twin technology. So how does digital twin actually works? Looking at this picture, I'm going to be looking at how digital twin actually works. Let me give you a scenario. From this picture you are seeing, you can see a physical and a digital counterpart. Now, imagine you have a manufacturing facility and you want to optimize the efficiency by creating a digital twin of the factories. So you can collect a real-time data from various sensors installed throughout the factory. Now, this data is then feeding into the virtual models, creating a mirror image of what is happening in the real world. In that particular term, that is what we call a digital twin, because we have been able to interconnect the physical factories and the digital factories to understand how the building is actually behaving. That is what we call a digital twin technology. So, real world applications of digital twin. Digital twin has an incredibly diverse range of industries where it can be used. So we are going to be looking at various industries that this technology can be used. So the first industry here is the manufacturing industry. Now, digital twin is being used in this aspect of industries to optimize production line, to reduce downtimes, and to enhance the product qualities, because when that technology is being implemented in such industries, there's high tendency that the operator or the technicians or the digital construction, the digital guys in that department understand how and which different factory machines can work digitally before it is being implemented on site. So this allows them to be able to see the mechanical workflow of those items in the digital world. So the application of digital technology helps to reduce downtimes, and we know how downtimes can be costly in the manufacturing sector. So the next industry here is the healthcare sector. It's no news that technology is breaking ground majorly also in the healthcare. Digital twin can help to create a personalized patient models and assist in surgical planning and improve the medical researches, because we've seen in a different case of people performing operation virtually. This cannot just be done without the help of technology such as the digital twin. So digital twin, it helps to enhance and improve the surgical planning. The next industry here, it is urban planning. That is when we can talk about the construction industry and the infrastructural planning. So now when we look at urban planning, it's the application of digital twins can help city planners to reduce and simulate traffic, can improve the energy consumptions in order to build a smart cities, because we've seen different simulation processes of infrastructural projects, for example like a bridge and the likes. It helps it helps professionals in the construction industry to make a better decisions when a proper simulation of building an infrastructural project has been done in construction industry. The next one now, the last application is the aerospace. Like we said earlier on, there are diverse ways that digital twins can be used. So in aerospace, it is not left behind. Like I've watched videos on YouTube sometimes ago that there is no airplane that is being manufactured that doesn't have each digital replica with the application of sensor to give real-time information to the pilot, to the engineering team, to the back-end teams guys. So digital twin it has come to stay, and it's a need for industry leaders to partner to this technology to help to improve the construction industry. It is obvious that construction industry are always laggard to adapt to the advancement of technology, but it's time for us to be the young generations, the young people in this sector, to take ease and do things more. So next now, we're going to be looking at the various stages that how we can apply a real-time data management techniques in a digital twin world. Now, the first step here for us to do is to create a digital twin itself. Now, when we talk about creating a digital twin, there are different tools that we can use to create a digital twins. And since we have already established that digital twin is a digital replica of a physical element, so there's a need for us to understand that we need to use different tools to create it. And those tools they are called platforms, and we are going to be looking at various platforms that these digital twins can be used. First platform here is the Microsoft Azure. It's called Microsoft Azure Digital Twins. Now, what does this platform do? This platform offers a scalable and flexible environment for creating a digital twin models for buildings and infrastructures. Now, this platform helps to integrate with the Azure ecosystems, providing various tools for data analytics and visualization. It is based on how you can use it. Now, you can always check it on the Microsoft website, and it is very accessible and very user friendly. Now, the next platform here we'll be looking at here is the Bentley iTwin platforms. Now, what is Bentley iTwin platform? This platform is designed for infrastructure and building operations. Now, it enables the creation of digital twins for better asset management and decisions. Now, it emphasizes the integration with BIM models and other designs. So, one thing about one difference between the iTunes and the Microsoft Azure is that the iTunes can work well majorly for buildings, operations, and infrastructures. So it helps you to be integrating data from infrastructural projects better than the Azure. Every platform has their pros and cons. It all depends on whatever your company or your decisions comes to play. So the next platform we will be looking at here is called the Autodesk Tandem. This is one of the most commonly used in the AEC sectors, because Autodesk is a well-known name by all professionals in the environment. Now, this product is from Autodesk, as it is being said, and it helps in the development of digital twin model. The next step here, it is what we call the data collections. Now, there are different methodologies to collect data collection, but what data can you collect? What can you use to collect it? That's when we talk about the deployment of IoT devices and sensors throughout the buildings. So when this is being done, informations and data are being collected in real time, and the information that has been collected are divided into 4 parts, where the first one is called the environmental parameters. This talks about the environment, the weather conditions, the nature of the buildings, the location of the buildings, the climatic conditions of that particular environment. This is when those parameters are being collected by the IoT devices, because they have been calibrated based on their localizations. Now, the next item here is the occupancy level. We need to know, because all buildings are different. Though they might be the same, they might look alike, but they can't behave same way at every point in time, because different human beings, we have different human natures, we have different grade of people that are going to be in the building. So what can help you to understand those data are the sensors, are the IoT devices you place in those areas, because whatever sensor, whatever data which is being fed into the occupancy level in the digital world. Now, so the occupancy level is talking about what grade is it? Is it children? Is it adult? Is it old people that is in that particular environment, that's in that particular building? The information needs to be collected for proper interpretations. Now, the next one here is talking about the equipment status. What are the equipment in the building? Is it a factory? What are the equipment in a factory? Is it an hospital? What are the equipment in a hospital? Those informations needs to be connected, because it will able to be telling us on the energy usage, the lighting usage, and the likes on that particular building. So these sensors can help. So in different IoT sensors that will be used can help to collect data about those equipment status. And lastly is the energy. What is the energy rating per year? What is the energy rating per month? What is the energy rating per building? And these informations are needed in order to help our digital replica of our building to understand our building better. Next slide here is going to talk about the next steps, which is called the data integration. What are we integrating? We've understand that we have collected some data which is from the buildings, based on the occupancy level, the energy, the environment parameters. Those data have been collected, so they need to be integrated. So integrate data from different building systems, the energy, the HVAC, and the security into a unified twin platform for comprehensive insights. So like we said earlier on, those sensors sense data from the building, from the physical twin to the digital twin through an integration format, and those information formats and platforms, they are the platform we talked about in the previous slide. So you can see everything work collaboratively. So the platform serve as an intermediary between the physical twin and the digital twin, and sensors sense in data in and out in real time in order to give a comprehensive insight. And you can see we need HVAC data, lighting data, and security data can also be integrated into the twin platform. Next slide here, which is talking about the step 4, which is the real-time monitoring and control. I've been able to collect my data, I've been able to integrate my data. Now it's time for me to understand what my data is talking about and control it in order to give a good insight. And there are 3 steps which is being done in this particular stage. The first step is called the dashboard visualization. In the dashboard visualization, there are different technologies that can be used here. You can use Power BI, you can use Python, you can use Tableau. Various parameters and various dashboards can be used here in order to give insight on what you are doing. The next things to do here is to the real-time alert systems, because this enables automated alerts and notifications to promptly inform the facility managers of critical events, ensuring a swift response, because there's a need for us to create alert systems, make an alert system to be integrated with that particular twin and the physical assets, so that if there is any issues on the physical asset, there's an alert system that will be on the digital twins, which can give the facility managers and information and notification for you to know where to check when there's an issues in the real physical twin. Now, the last thing here to do is called the remote control. because I've been able to establish a dashboard. I've been able to see the insight, gain an insight of what I'm saying, and I'm able to establish a reporting or alerting system where I can see, okay, where there are issues in my physical twin. Now there's a need for me to control it. Now this aspect, it empowers the facility managers to remotely adjust the building systems, optimizing the energy usage, and ensuring the occupier comfort with a real-time data insight, which is being done on the visualization dashboard. This brings us to the next step, which is called the predictive maintenance. There's a need for us to employ an AI-driven analytics to monitor the equipment health and performance trend from the historical data, because this will give us insights for every issues that might occur in the future. Now I want to talk about the predictive alert. This is the ability for us to implement predictive maintenance strategies or routine in order to forecast any potential equipment failures or any maintenance needed. Now, these alerts and this predictive alerts, it helps to minimize downtimes and the repair costs. The next step is called the energy optimization, and under this real-time data technique steps, there are 3 things you need to do. The first thing you need to do, the energy consumptions analysis, because if we're able to utilize digital twins to analyze the consumption pattern across different areas of the building, it will be able to give us the insight of where area of the building is consuming energy most. The second step here is called the energy efficiency measure. So when we've been able to identify the areas that is consuming energy, there's a need for us to measure it by maybe adjusting the HVAC schedules, optimizing the lighting controls, and managing the peak demand, because it is very obvious that not every hours of the day is going to be the peak period. For example, maybe 9 to 5 is a peak period probably in an office or a factory, and at the evening hour it's going to be reduced. So at that peak period, there's a need for us to measure well and to control whatever equipment that will be able to be needing in order to reduce our energy consumption. So the next one now is called the sustainability initiative. Now this approach, it helps us to set some energy reduction targets and track progress towards achieving sustainability goals. This leads us to the next slide, which talks about scenario simulations and decisions making. So on this aspect, there's a need for us to consider the what if analysis questions within the digital twin platforms to evaluate the potential impact of various building modifications and operational changes. Because when we ask questions that why is this and this is happening at this particular hour, that gives us a proper insight to lead us to what we call informed decisions making. Because the use of insights from scenario simulations to make a data-driven decisions, optimizing the building designs and operation for better performances, because this helps us to make a proper and informed decisions from the stakeholders. Now, this leads us to the benefit of using the digital twin technology for building management and optimizations. Now, the first benefit that we are going to be looking at here is called the real-time monitoring and insights. There's a need for us to understand the importance of real-time monitoring, because the use of digital twin technology enables the continuous real-time monitoring of buildings, such as the temperatures, the humidities, the occupancy, the energy consumptions, because this data-driven approach provides a valuable insight into our building operation by identifying any inefficiency in the buildings or any potential issues, because at instantly we can see what is happening in our building. For example, probably the heater is bad, IoT device send informations to our models for us to make any necessary adjustments. So the next benefit here is called the predictive maintenance. By analyzing data from sensors and equipment, now the digital twin can predict the maintenance routine and the maintenance requirement for any equipment or any device in our building. Now, this approach helps to prevent unexpected breakdowns, reduce downtimes, and extend the lifespan of the building assets. And we all know that the operational cost is high. There's a need for us to reduce our maintenance strategies and reduce our maintenance costs in order to reduce the operational cost in the long run. The next benefit that digital twin helps is energy efficiency and optimizations, because digital twins, it helps to optimize the energy usage by analyzing the real-time data to identify areas of improvement in our buildings, because this can be by adjusting the cooling systems, the heating systems, the lighting systems, and ventilation systems dynamically. And we all know that these are done automatically based on the parameters that we have put in, based on the data collections, based on the data integrations, and data on the platform we are using, because everything will be done automatically. So probably there will be some times in a building that the heating system will not be needed. All heating parameters are put off, all cooling parameters are put off automatically without little or no human input. So when you have a digital twin platforms, it will help you to put everything in places so that you can reducing your energy and optimizing it. Now, the next benefit of digital twin is called the simulation and testing. This is one area that I really love much about digital twin, because it helps to tell you your what if scenario cases by enabling the facility manager to assess any impact of the changes before implementing it in a physical environment, because this lowers the risk of costly errors that helps to optimize building layers and processes. Because if we don't simulate our models before we start actualizing it on site, there might be an unnecessary errors that we may have just do away with in the inception stage of the designs. Another benefit of digital twin is called the remote monitoring and control. Now, digital twin, it facilitates a remote monitoring and control of a building system, because when operator can access any of his data on a real time wherever he is in the world, and this leads to more efficient and building management, particularly when you have a larger larger scales of projects, and you imagine that how can you manage this without the effective of a technology such as digital twin. So it is very difficult for us to do this manually. In simple terms here, digital twins helps us to monitor and control our building wherever we are, irrespective of the large or the scale of it. The next one here is called a data-driven decision. Based on the simulation and testing that we have done earlier, digital twins helps with an abundant real-time of historical data through every analysis that we have done. Now, this helps us to make a well-informed decisions by the stakeholders based on the data insights that it has been generated on the visualization platform. Now, this ensures for a more strategic approach to building operations and resources and allocations, because there will be a need for us to know where we need to put some things in places based on the data-driven decisions that we have gotten. Now, we'll be looking at the challenges here on the application of digital twins for real-time data management. Now, before we move forward, let me recap on the definitions of digital twin based on our previous slide. Digital twin is like a virtual siblings of a physical buildings, always connected through a real-time data. It helps us to monitor, analyze, simulate building operations to make informed decisions. Being knowing that there are challenges that this poses. Now, the first challenges here is, let's look at data volumes and complexity. Now, imagine a building equipped with numerous sensors and IoT devices, generating loads and heap of data every second. Handling such a massive data can be challenging, no doubt about that. Now, the complexity of these data requires careful management to extract the meaningful insight, because at any point of misuse of data management, it's going to lead to poor insight, and that is not what we want to give to the clients. So there is a need for us to be careful with when it comes to the larger projects and complex projects. Now, the next challenges that we have that is common in these approaches: data qualities and reliability. Now, let's imagine garbage in, garbage out scenario. When a sensor is faulty, and believe me, we are going to be having a poor insight. When we have faulty sensors, data gaps, and all inaccuracies can lead to wrong parts, and this is going to be a mess, and which we don't want to get ourselves into. The next challenge here is what we call data integration and interoperability. Let's imagine our buildings house an array of different systems from different vendors, different subcontractors. Integrating data from diverse sources into a single digital models, like the model we talked about in the previous slides, Microsoft Azure Tandem from Autodesk. Let's imagine bringing all vendors into one single platform. It's like bringing everyone to come and dance on the same tune. So interoperability is the key to harmonize data flow, which we need to be very, very careful when implementing digital twin technology in our various facets of work. Now, the next challenge here is called data security. It is evident that with the advent of technology, the issue of cyber attack, there's issue of cyber crimes in the internet now. There's the need for us to ensure a careful decision making, what we are going to be using as our privacy platform, as our privacy tools. There are a lot of them in the internet that we can use and make purchase of. Now, because if we don't do that, you'll find out that all information about your buildings, your floor plans, your building plans is being on the internet, and this is going to be a mess on the company's name and company's reputations. The next challenges here is called scalability. As our building evolve and expand, so does the complexity of our digital twins data demand. So scalability is like stretching our platform capability to accommodate a growth without breaking its ends. So there is a need for us to know how and when we need to scale, because if we scale at the wrong time, our system is going to crash. So there's a need for us to know when to scale. So a data engineer is needed at every point in time for us to know when and where to scale based on the platform we are using. Now, the next challenge here is the cost consideration. It is very evident that the initial cost of implementing technology might be higher, but in the long run, it is very, very considerable, because this has been tested. The cost of software, the cost of ideas, the cost of training, and the cost of the technology we are going to be using, that is the platform. So there's a need for us to understand all these things. So there is a need for us to be cost effective when choosing our platforms and when choosing our technology. In conclusion, we've been able to talk about the 7 strategic steps in building a real-time data management with a digital twin technology. We're talking about data collections, data integrations, the creating of digital twins, platforms, different platforms. We've talked about that. There's a need for us to know that when we make a decision on implementing this technology, we need to undertake the necessary step in order for us not to run into a mess. We've also discussed about the benefits and the challenges associated with this. And from these benefits and the challenges, you can make a decisions on when and why and which softwares or hardwares or implementation strategies that we need to put in place. I will leave you with this word. Poor implementation is equivalent to what? Expensive implementations when it is not done right. So before you make decisions on implementation of digital twin, get the right expert, the right teams before you do so. Thank you for your listening and thank you for your time. I hope you've learned 1 or 2 valuable lessons from these sessions. And if you need any more clarifications, you can reach out to me on LinkedIn, Olayemi Usman, or you can write a mail to me. I'm willing to respond to your questions. Thank you for your time, and I hope you enjoy the rest of your day.